we're discussing is big data and trying to analyse what the impact of this major technological scientific change is on the way in which the society operates. Obviously, the function of the academy, in a way, is to understand what change is taking place. It's to try and analyse why it's changing place, who it will impact in what ways, what protections we need against the changes which are happening from a number of different points of view. And there are very few subjects which are as important from that point of view as big data. Technological change has meant that really in recent years there's been a massive acceleration in the amount of information that exists in different forms, collected by a variety of different people, in a variety of different ways, by governments, by agencies, by private corporations, and so on. Many organisations take decisions on the basis of what the big data tells them, having been analysed. Lots of moral, ethical questions about the way in which that's done, the implications for society as a whole, the implications for individuals whose data is being used and collected in a variety of different ways. And when Hussein discussed this with me, what he explained was a very strong desire to engage people in this wider discussion about what is really a very, very big social change which is happening as we speak. And to do that, of course, by basic research, which is happening the whole time, but also by a series of lectures and other events which are taking place over the course of this autumn. And this is just the first in a series of events which are trying to illuminate this particular aspect. I should say that I think the subject is itself often very confusing to people. People find it difficult to think through what the meaning of this, what is actually being done. There are a lot of fears that people have, some justified, others less so. So it's really excellent this evening that we have a first-class panel to lead us through a discussion on these questions. And the way the evening is going to work is I'll do a series of presentations, and I'll tell you now what they will be, and then we'll have a Q&A and discussion with the people who've made the presentations to try and draw out the different areas. Ruth Hancock is going to introduce the discussion by a brief description of the aims and operation of the Economic and Social Research Council Business and Local Government Data Research Centre, in particular the issues around the use of big data in healthcare and what that means to all of us in a variety of different ways. She will kick off, as I say, principally talking about healthcare, but also describing the whole concept of the way this research is being done. She'll be followed by Phil Jones, who's going to do a presentation on big data and climate change, another key area where big data has changed the way in which people understand what's happening, but particularly within that, the modelling of climate change. How can we understand how climate change happens or not? And as everybody here will appreciate, that is itself a very controversial area, both the subject itself, but also the way in which the science has been applied to trying to understand that subject. And I think that Phil will give some insights into that in explaining what we're going to do. And then finally, Paul Bernal is going to make the presentation on big data and privacy. I referred a second or two ago to the fact there are very substantial ethical and other questions around the use of big data. And I think Paul is going to try and illuminate some of those for us to understand what the contradictions and issues are that we really need to try and understand. And then, as I say, at the end of those three presentations, we'll move to the table there and have a Q&A and discussion about the issues which have been raised. I think what the selection of the panel demonstrates is that the impact of big data goes across a whole series of major academic disciplines, and it's very important to try and think of it in a holistic way, if that's at all possible. So I'm going to kick off with Ruth Hancock and ask Ruth to come and lead us off this evening. Thank you, Ruth.
Well, first of all, thank you to everybody for coming to this first in a series of events on big data that is being put on as part of, as Charles said, the Economic and Social Research Council's Data Research Centre on Business and Local Government Data. It occurred to me that it's just over 2 years ago that I had my arm twisted to be the UEA lead in the bid to the Economic and Social Research Council for this centre, working with colleagues at Essex and Kent and elsewhere. I actually don't have any particular expertise in big data myself. I'm not even sure I know what big data means, but that I think is something that we'll be talking about a bit more. My own background is in use of survey data for research, so data that have been collected specifically for the purposes of undertaking research. And what I understand by big data in the context of our centre is data that has been generated not specifically for research purposes, but has been generated by businesses and local government in the course of doing their day-to-day activities, discharging their day-to-day duties and undertaking business. So that's the concept that underpins the Business and Local Government Data Research Centre. So what I wanted to do, it's early days in the centre, so what I wanted to do really was just to introduce you to it in general terms, and then talk a little bit about the specific area that I'm most involved in and which perhaps raises some of the most sensitive issues. So we've been funded by the ESRC under their Big Data Network. The centre is funded to the tune of about 5 million in total, of which about 1 million is coming to UEA. And we have 5 years of funding. We started in January 2014. The centre is a partnership between the universities who together form the Eastern ARC, the Eastern Academic Research Consortium. That's the universities of Essex, UEA and Kent. We also have a contribution from the London School of Economics. And we're working closely with local government, particularly those local authorities in our own area in the east of England. So we're working closely with Norfolk County Council, with Essex, with Kent and with Medway. The aim of the centre is to exploit data to benefit society, and this is partly through demonstration research projects. So part of the purpose of the centre is to facilitate access to data for researchers in general, but what we want to do within the centre, within our 5 years, is to demonstrate that potential, not least because we think that will be a way to further facilitate access to such data. We also want, therefore, by facilitating access to such data, to stimulate innovative policy and practice relevant research. And that was an important part for aiming for the ESRC. The centre will and has to operate under the highest ethical standards. And I'm going to say a bit more about this in a minute, but all the data that we will be using will be completely anonymised, and we have to use it in a non-disclosive way. That is to say, we have to protect the confidentiality of any individuals about whom we have data, but we will not know who those individuals are. And the centre includes a training and knowledge change programme as well. It involves all 4 UEA faculties. It involves a number of schools within those faculties. So Norwich Medical School, where I'm based, is involved. The School of Social Work is involved. The Norwich Business School is involved. The Centre for Competition Policy, which itself crosses business, economics and law, is involved. The School of Computer Science is involved. The School of Environmental Sciences. And last, but by no means least, the School of Politics, Philosophy, Language and Communication Studies. And that, of course, is home to Hussein Qasim, who has worked tirelessly to kick this series of lectures off, and I would like to thank him very much for that. There are a number of research themes that we set out in our application to the ESRC. There is a methodological stream, which is led from the University of Essex, but with considerable input from the UEA School of Computing Sciences. There is a research theme on regional drivers of economic growth. That's led from the University of Essex, but our business school is involved too. There is a research theme on green infrastructure, which is led by the UEA School of Environmental Sciences. And then finally, and the one that I'm going to be talking a little bit about today, is the theme of research for supporting vulnerable people. That is led by UEA. It involves the Schools of Social Work, Medicine, Business, and the Centre for Competition Policy. And it also has input from the Personal Social Services Research Unit based at Kent and at the London School of Economics. So we're drawing in a lot of people across the institutions that are involved in this centre in this particular theme. And as I said, that's the one I'm going to just say a little bit about, say where we've got to and what some of the challenges that have arisen are. The kinds of research that we're interested in concern both vulnerable children and young people and vulnerability perhaps at the other end of the age spectrum. Reflecting some of the strengths at UEA, my own work is in the area of older people. The School of Social Work have a long tradition of working in the area of vulnerable children and families. So understanding the pathways and outcomes for children in need, at risk and in care is one of the strands of research within this theme. Early identification of adults or older people at risk of needing high-cost social care, whether it's home care or residential care. Promoting a sustainable market for care. Local authorities now have, under the 2014 Care Act, a responsibility to promote a sustainable market for care. Local authority data themselves have huge potential for research in this area, but that potential could be even greater if we are able to link their data to data from the health service or education data, so that we can bring together information about people's health, education, and their social care needs and receipt of services and ultimately outcome. Working with local authority data, well, in some ways it's both the best and worst of times to be doing this. The local authorities that we're working with and talking to are desperate to have research which would help them square the circle of decreasing resources and increasing demand. So on the one hand, they're very, very keen that we should make use of their data to answer some of the difficult research questions which might enable them both to keep within their budgets but to meet the needs in their area. Technology is or should be on our side. You know, when I started in work, the power of computers was nothing compared with what it is now. So in one sense, technology is on our side. On the other hand, the constraint that the local authorities are on at the moment means that they have very little time to do anything than their day jobs, which is a lot of firefighting. So while we have encountered a lot of enthusiasm for working with us, their ability to actually devote time to this is very limited. And there is, of course, some heightened sensitivity around data sharing and linking data across different systems. And that, I'm sure, is something that we're going to talk about a bit more. What I did want to say is something about the mechanisms that we will be using to safeguard data and safeguard the privacy of individuals whose data we might want to use. All data will be anonymised. As researchers, we are not interested in any individual. We are only interested in using the data to identify patterns and to identify possible causal pathways. For the most sensitive data, and even this would be still anonymised, but there may be some kinds of data that are particularly sensitive. Researcher access will be via so-called safe rooms, and we have one nearly ready for operation at UEA in Elizabeth Fry building. Access to these safe rooms will be controlled. It will only be possible for accredited researchers who have undergone training and passed a test, and I'm going to have to do that quite soon. Access will be via so-called thin clients, what I think of, used to think of as dumb terminals, connected only to the server where data are stored, and with no access to the internet. People using the room will not be allowed to take in mobile phones, paper or pens, or take them out, so that there is no possibility of any of the data that they are accessing being removed from that environment without it having been screened first. There will be monitoring by security cameras, so no sleeping on the job, but also, to make sure that you're not doing things like writing data down on your hand. Output will be, from any analysis that you do, will be screened by experts in non-disclosure to make sure that, if data have been produced, tables, fiscal output and so on, there is no way in which any individual could be identified from that. And so it will only be released for further use, for example, to include in research papers after it's gone through that screening process. What we're finding in working with local authorities is there are a number of keys to success. The first is to identify and specify a research question of common interest. The second, I think we've learned, is to start narrow, but with a potential to widen. And by that I mean both in terms of the data and the research question. So while I guess we started thinking, wouldn't it be lovely to be able to have health data, social care data, educational data all linked, I think that is just a bit of a challenge too far to get the thing going. So starting perhaps with a small self-contained type of data, but with the possibility of widening it to link with other data. We have to recognise the constraints that local authorities are on, and we have to use our resources to help them. We do have resources to appoint, or have just recently appointed, researchers, and they may be able to help the local authorities help us. And I'm pleased to say that we are now making some progress with Norwich County Council. It has felt like a long journey, quite painful, but perhaps quite rightly so too, and with other councils. So we have data exchange agreements beginning to be in place. We are expecting some data imminently, and we're gaining a much better understanding of the data that they have, and how it is structured and how we might be able to make use of it. Yes, sorry, Norfolk County Council rather than Norwich County Council. So, as I said, it is early days, so I would just ask you at this stage to watch this space, and I'm now looking forward to listening to the talks of the two other speakers who've been working in big data much longer than I have.
Good evening, everyone. I'm going to be giving you a different sort of view on what big data is in the climate context. And so, talk a bit about climate data and what it is in terms of observations, particularly climate models. So I'll then introduce what climate models are, some idea about data sizes and how these data sizes, how we're going to be probably changing the way we're working in the future. Then towards the end, I'll talk a bit about what we're more well known for in terms of global temperatures, and then some work where we're trying to link observations to the models in terms of some projections of extremes in the future. And we're doing this for the World Health Organization, and some of these results will be released next week in Geneva as part of the lead up to the big climate meeting at the end of November, early December in Paris. To just give you some idea about the numbers of data we're talking about here, in terms of the storage of data, what's actually involved in climate data. You may think climate data is sort of weather data taken at weather stations. Well, if you look along the bottom, the conventional stuff, weather stations, weather balloons, etc., is that little green bit right at the bottom. two other areas. The blue is the data we're getting from satellites. We're getting a lot more from satellites, and this is the projections of how much we're going to expect over the next 15 years or so. And it's also radar data, so there's a lot of sort of automated data coming in. And then the final one is the yellow one here, and this is climate model data. So these are our simulations of the climate system, and this includes not just our simulations for climate, the past and the future, but also weather forecasts as well, and the same code that's being used here. And there's a couple of aspects here. Satellites estimate temperatures, but they do it in a roundabout way. Radars estimate precipitation rate. So these are all things you see you see some aspects of these on the weather forecast every night. So but very little of this is true observations where you've got a person going out reading an instrument. It's much more automated now than it ever was. Now, what is a climate model? So basically, they're extensions of weather models. So the weather forecast you see every night at the end of the news is a climate model. They're one and the same thing. So the ones you see in Britain run by the Met Office, it's the same computer code. It does the weather forecast, it does the climate projections. And they're essentially, you're solving the equations of physics, moving heat and momentum around in the atmosphere and in the ocean. And where you can't do that with regard to specific clouds, you'll parameterize the process. So in weather, the key thing is to get the dynamics right, where the air is flowing. It determines whether it's going to be cold or warm the following day. In the climate area, the key thing is to get the thermodynamics right, where the heat is going in and out. And that's much more on a longer time scale. The dynamics is much more on a day-to-day and week-to-week time scale. And essentially what you're doing there in all these is you've got now what we call an Earth system model. So you're solving atmospheric processes, ocean processes, you're simulating ice sheets, and you're importantly getting into the carbon cycle. So the models are doing these sort of things, and then eventually, when you get a full Earth system model, you will get into the more models of the hydrology, the ecosystems, and eventually you've got to get into policy as well. But at the moment, these models are just that bottom right part of this diagram. And a lot of this, the reason we've got so much of this data is we've got many modelling centres, but also that model output has to be kept. Not just the climate data, the weather data has to be kept for a number of years in certain countries. In the US, they've got to keep all the weather forecasts for the next up to 30 years from now, in case there's some court case resulting from that in the future. So they can't just get rid of the data at the end of the weather forecast period. It all has to be kept. Climate models are going the same way, in that if you're making decisions now that might involve some 50 years into the future, you've got to keep that data to make sure that those decisions were the best ones that could have been made at the time with regards to possible future litigation of some sort. And also the reason the model output is getting much bigger is that you're resolving more and more of the processes. So this is looking back over the IPCC, which is the Intergovernmental Panel on Climate Change cycles, going back to 1990 with the first report, and you've got the last report in 2013. So you can see how the resolution of the models has improved. So you can see now that at the bottom there, Europe looks a bit more like Europe, where at the top you can see Britain has fell off on the scale of the resolution. It wasn't really there. So, and you're also resolving more and more of the processes now than you were years and years ago. So you're doing more things, you're looking at the oceans integrated in, you've got ice sheets integrated in, and you're moving air around and you're doing all the chemical transformations that are going on with aerosols and other gaseous substances that are released into the atmosphere. So you've got many more processes going on. You're producing more and more output at more and more locations over the Earth's surface and in the column of the atmosphere and in the depths of the ocean. So I've got one big quote here. It's from a US assessment of advanced climate modelling. So without substantial research effort into new methods of storage, data dissemination, data semantics and visualization, all aimed at bringing analysis and computation to the data, rather than trying to download the data and perform analysis locally, it is likely that the data might become frustratingly inaccessible to most users. This is the amount of data that's currently moving around the world to be analysed. So what they're getting at is that you're going to do things more centrally on bigger computers. And what's being proposed in Britain is something called the Jasmine system. So this is data from all these model runs, weather forecasts, etc., stored centrally. Then users have accounts, which they can then run programs that will do things very quickly on this data and send you back the results. And so all this data will be stored there, and there'll be observations as well. And this means that the vast amounts of data transfer that's going on now won't be happening. You won't have to download all this data from different centres and then analyse it locally. You'll be able to all be at one place, and you can do the same things to it. So you can have the software that can achieve this is being continually updated and improved. It's obviously then got the issue of how you're going to resource this or fund it. So there's different ways that Jasmine might be run and financed in the future. But it's a different way of doing things, rather than trying to get the data to the person who wants to do the analysis, but you then have it at a central place. It's similar to what Ruth was saying, it's just a much bigger amount of data. There's a few problems with this, which we have to address in the future. So there's this dramatic increase in data storage and in the speed of the computers that are producing that data and analysing that data. Now with this speed comes greater power source needed. So for example, the Met Office in Exeter has a new computer, and it currently requires 2.5 megawatts to run it. And this is about 30% of what Norwich uses, by the way. And it's even bigger for Exeter. So these, all around the world, you've got various weather, climate and operational centres doing this, and they expect their needs to increase in the coming years by about 10 times. So if you're going to improve weather forecasts, you're going to improve the detail from the climate projections, you're going to need to get down to more and more fine scales. So you're going to need more and more power. Now, currently no climate modelling centre has figured out what to do with this waste heat that comes from this to keep the system cool. Met Office actually heat the building. But obviously you can't do that in summer. So this is not just applying this to the climate model community and the weather community. This is a problem for big computers everywhere. This dramatic extra use of power, what you do with this waste heat. But it's really important for the climate to be seen, to be actually thinking about it and trying to sort out what to do with this extra heat. Maybe there's some sort of centralised power system that you might have had in the Soviet Union, in integrated systems that you can sort of bring in. But that's what's trying to be thought about at the moment, as to what to do with this. And what it does also mean is these climate data volumes are becoming increasingly incompatible with the citizen science community idea, because a sort of individual user at a university, unless they're linked into another group, might not be able to gain access to some of these data sets in the future. And certainly someone who I might be soon when I've retired won't be able to access this unless through some contacts. So that's where the big data in the climate area, where the computing is going and the resource allocation, etc. I want to now move to two things at the end here, first on global temperatures and then on extremes. So we're one of 4 centres around the world, and we work jointly with the Met Office. So the Climatic Research Unit looks at the land areas of the world, and the Met Office looks at the oceans, and we combine that into a global temperature average. There are 3 groups in the US also doing this, at NOAA, which is the American Weather Service, NASA, and also another group called BEST. Now BEST is a very clearly contrived acronym, the Berkeley Earth Surface Temperature Group. So it's a group of physicists at Berkeley who had some money from a skeptic science group to prove that the other three were wrong. And so they had a grant of about $600,000, and they basically showed that the other three groups were right. And their funding stopped then. So here's an example of what sort of data we're talking about here. So this is the land areas, and some of the groups try to bamboozle you with numbers and saying they're using thousands and thousands of stations. Well, the key thing about where the data are, you can get thousands of stations if you really want that. And you will have more and more stations where you've already got them in North America, Europe, Australia, Japan. You can get more data from there. Really, when you see maps of data coverage, you want to look at places you know might be difficult to get data. So one is the Antarctic. Brazil is always a problem, Tibet and parts of Africa. So those are the places that have the gaps. And we've worked tremendously hard trying to get more data for those areas rather than more for the US. And this is now the land areas. This is comparing the global average from the land areas from the different groups. So basically, we can't see it at all well now on that big screen, but there is a range that's in grey, it doesn't come out very well, that we've developed. And all the other groups are essentially within that range. So this new group, BEST, is there in the green line, very similar to the black line, which is L1. What's also in there is the American Weather Service and NOAA. They've also produced this series without any adjustments to the temperature data. We produce adjustments, the other groups do it as well, to correct for a lot of problems at stations. And a lot of skeptic groups say these adjustments make it warmer. But if you look at the orange line there, you can barely see it, but it's all within the same range. The adjustments to the land data make very little difference. But we do them to mean that it's accurate at every place rather than the global average. Because no one lives at the globe, everyone lives locally. Just to also show you how robust this record is. There's a lot of work done about data in the United States. This top plot, or the bottom one for the globe, one for the Northern Hemisphere, show that if you remove all the data from the contiguous 48 US states, just remove it and leave that blank, then you get the red line. If you leave it in, you get the black line. So you can see removing the US, taking it out, makes no difference until you get back into the 19th century. So individual countries are not crucial to the global average. We've done this even for the Soviet Union, and it still doesn't make that much difference, taking out that large country. The Met Office do this work now, and it's working with marine data. So we're talking here about sea surface temperatures. And this is an example of how much data comes in May 2010. So you've got about 1.4 million observations coming in. They're coming in from a variety of sources. So the blue ones are ships taking marine measurements. The red ones are drifting buoys, which have been put in since the 70s to try and improve coverage, particularly in the Southern Hemisphere and the tropics. They're also put in to improve weather forecasts in the Southern Hemisphere, but they produce a lot of sea surface temperature data. There's also some fixed buoys in the tropical Pacific, which are there to help us forecast El Nino events, which I'll come to later. Now, the marine data has more serious problems with quality and homogeneity and consistency through time. So there are two groups who are doing this. There's the Met Office in Exeter and the American Weather Service do this. And here you can see the grey a bit more, but the Met Office is black and the American group is red. But they've also shown their unadjusted data, which is the yellowy colour there, much colder in the period before about 1940 than the adjusted data. So if you don't make those adjustments, the world will be much warmer you hadn't made those before 1940. It would also be incompatible with the land data as well. So when you combine these, you see that we're looking here at all these records for land and ocean together. You can see that we are much warmer now than we were in the 19th century. Warming is in two parts, first part 20th century and since the mid-1970s. And right at the end, you can see what we can't. The last year is 2015, based on the first 8 months of the year. And it's the warmest year. It's the warmest year by a long way. And it's because of this El Nino event, which you may have heard about on the news, which started in the springtime this year, and it's going to go on to the next spring. And it warms up the whole tropical Eastern Pacific. And it's likely to lead to lots of flooding in heavy rains in California in the coming months. So California's drought should end once this event gets into the northern winter season when it rains in California. But it will also make this year the warmest year by miles, and it will probably make next year even warmer. So we will have 2015 as the warmest year, 2016 probably warmer still. The current warmest year is 2014, so the 3 warmest years will all be on the end. Now, that's the global average. Now, no one experiences the global average. We all live somewhere and we experience temperatures and rainfall locally. And it's those extremes that we experience. And it's those extremes that have the impacts. The big storm that's just gone through the Philippines, for example, and earlier events like that, and heavy rain somewhere else. So what we're doing for the World Health Organization is to take some indices that have been developed to look at extremes on both temperature and rainfall. And then we're going to produce those from the observations. We're then going to produce those from the climate models. And then look at those over specific parts of the world and specific countries. So next week, a number of country results are going to be released, which will look a bit like some of the figures I'm going to show you in a few minutes. And we're going to look at these for 2 scenarios into the future. So how we look at scenarios into the future are something called representation concentration pathways. So the one at 8.5 is effectively what's business as usual. If we don't do anything, that's what's going to happen. Another one is 2.6, which is a more green one. We actively try and reduce the amount of carbon dioxide reaching the atmosphere. And that does limit the projection to about 2 degrees Celsius above the pre-industrial period. There's a lot of issues that aren't scientific, that are more political, about when the pre-industrial period was. I mean, you may think you know when it was, but a lot of countries debate this at these big meetings in Paris, because if you have it further back in time, then potentially there's more money that they might be able to get from the developed countries. And so a lot of them want this period 1751 to 1800 under the belief that that was cooler than the period 1851 to 1900, 100 years later. But in reality, the second half of the 19th century was colder than the second half of the 18th century. So in these next plots, I'm going to show you in brown, it's going to be this business as usual type scenario, RCP 8.5, and in green, you're going to have the RCP 2.6. So first of all, we'll look at the global average this way. So that's the same curve I was showing, the sort of smaller numbers and a much bigger scale. And the business as usual is going to make us about 5 degrees warmer than we were in the beginning of the 20th century. And this range is from 18 different climate models, which have been run with this scenario for the past and for the future. So the green area is then this this attempt to reduce the carbon dioxide emissions to try and keep the temperature within the limit that the EU has put forward of 2 degrees Celsius, a warming of 2 degrees Celsius above the pre-industrial level. And so you can see that green one just about achieves that by 2100. You are about 1 to 2 degrees Celsius warmer than at the beginning of the 20th century. So, but then we're going to look at a number of these. Maybe you can't see these, but these are for two of the countries. On the left is for the UK, and on the right is for India. So these are averages over those two countries, and we're looking at a number of different indices here. We're looking at warm and cold spell durations, and they're because they might have an impact on human health. Basically, in both countries, the warm spell durations increase, and the cold spell durations decrease. And the cold spell duration ones decrease quite dramatically. Then the other ones are numbers of warm days and warm nights, cold days and cold nights. So looking at daytime and nighttime temperatures there. And the other ones are then precipitation ones, looking at heavy rainfall days, counts of heavy rainfall days as well, and the numbers of dry days. And if you look closely at these, you'll see some of them have look a lot more like the global temperature, and some of them don't do much at all. And the ones that don't do much at all are mainly the rainfall ones. The projections of rainfall are very uncertain from these models. There's more dispersion between the models, and there's generally not that much happening to rainfall. There might be some increases in some extremes, but it's not, there's no overall change in average rainfall over the world. Some regions get a bit wetter and some a bit drier. Maybe some changes in extremes, but not that much change. Whereas the big thing that all these diagrams show for every country that we've got, and they're spread around the world, is that there'll be a decrease in cold spells, a decrease in cold nights and cold days, and an increase in warm days, warm nights and warm spells. And you can see two other interesting things on some of these different plots. So the blue is the observational data, which is inside the model ranges here. And it's obviously good observational data in the UK to go back in time to do this. In India, the blue goes back to the turn of the century for rainfall. But the temperature ones don't go back before the 1950s. And that's just because the Indian Met Department has not fully digitized all the observational data, because they're much more interested in rainfall in India. So that got priority when they digitized things. A lot of countries have done similar things. If there's an emphasis on something, they will digitize that, but not all the other variables as well. So in conclusion, data storage and computer speeds are both increasing, and I mentioned this Jasmine thing as a way of analyzing all this data. And I think this is going to be the way many the climate groups here at UEA begin to work, using this type of way of analysing the data. The actual truly observational data is very small compared to all this model-generated data, satellite data, and something called reanalysis. So in terms of big data, what we're producing is the generated data, the analyses. It's not more observations. The global temperature is increasing. This year will be the warmest year. You'll hear more about this towards the end of the year with this big meeting in Paris. 2016 could be warmer still. The reason these 2 years are so warm is because there's a big El Nino event occurring in the eastern equatorial Pacific. There was a big one in 97-98, there's another one in 2009-10, and there's one now. And this one seems to be approaching the size of the one in 97-98, which was the biggest event of the 20th century. And during El Nino events, the global temperature is sort of lagging behind that by about 6 months. So although this El Nino event will finish about the spring next year, it will probably make 2016 warmer than 2015. Temperature extremes everywhere show dramatic increases in warm extremes and decreases in cold ones. The rainfall ones are less clear. There are some places that show heavy rainfall amounts increasing, but it's not always a clear picture as it is for temperature. So thank you very much.
Right, thank you very much. I'm Paul Bernal. I feel a little bit of a broad is perhaps the wrong word here. I don't do any big data analysis. And I haven't done any big data analysis. What I do more is I pick holes in other people's big data analysis. And I ask questions about whether this analysis is the right analysis to do and whether it's been done in the right way. What I am is a privacy person, and specifically a data privacy person. And I think the first thing to say is I've noticed already from the first two talks, nobody's tried to define what big data is. And I think that's actually one of the critical questions. Now, the data that Phil has just shown about climate is undoubtedly very big. I mean, it's spectacularly huge, and that's one of the issues. The data that Ruth was talking about isn't nearly as big in many different ways. And the data that I talk about is often significantly smaller than that. But there are certain things that are true about what we normally talk about in terms of big data that make it different from what I am labeling here small data. And the specific thing that I want to talk about that's different is that big data generally requires algorithmic or computer-based analysis in order to be actually useful. Whereas small data, in my own label, no one else uses this apart from me as far as I can tell, can generally be analysed by people. And there are significant differences between whether you get a computer to do things and whether the people do them. Now, of course, people intervene with the computers and sometimes use computers to help them, but the two are actually significantly different, as we will see from some of the examples I want to talk about. And I also noticed that Ruth mentioned anonymized data. And you notice when I write anonymized data, I put quotation marks around anonymized data because one of the biggest issues that we have in terms of privacy is that anonymized data can often be de-anonymized. And we also talk about de-identified data rather than anonymized data, because often what people think when they talk about anonymized data is simply we've taken the name away from it and therefore it's anonymized. But evidence has shown, there's consistent evidence, both from computer science and indeed from legal analysis of it, that you can re-identify the de-identified data. You can therefore de-anonymize the anonymized data. So the protection that you get for privacy by anonymization may not be as good as it seems. Another concept we talk about occasionally is private data and personal data. And again, I put private in quotation marks because it's not actually clear what people necessarily mean by private data. And I will talk a little bit about how privacy is something that people don't really know exactly what they mean. And legally, we talk about personal data, which is largely speaking any data that can be linked to a person, any data. But we also talk legally about sensitive personal data. Now, there's a legal definition in our data protection regime which defines sensitive personal data, and we quite naturally have more protection over it. It includes things like health data, which is one of the things we've talked about. It also includes things like political opinions, trade union membership, things like that. So, I'm supposed to talk about privacy. So what do we mean by privacy? Well, the first thing to say is it's very hard to define what we mean by privacy. Different people mean different things. Whole books have been written about how we define privacy. In a way, it doesn't matter. What is a problem is that it's hard to understand what people mean by privacy, and different people mean different things. And the consequence is that it's very easy to misunderstand privacy. And in particular, when you as a data professional are working with data, your understanding of what privacy is may be totally different from the person about whom you've gathered this data's understanding of what privacy is. You may not think it's private, they may think it is. And then you get a problem. And in relation to big data, we have specific issues in different directions. We have issues about how the data is gathered, and we have issues over the data that's derived from the data that's gathered. And we have an overwhelming issue in relation specifically to social media, which I will talk about at some length, about whether people have any expectation or any right to privacy over data that is deemed to be public. And some people may know I tweet rather a lot. Tweets are public. Does that mean that the data in tweets is therefore perfectly free for people to gather and analyse and do with what they will? And we will see how that actually plays out. So there are three questions I would want to ask about any of these in relation to privacy, any exercise you're doing with big data. First is it legal? Secondly, is it ethical? And thirdly, is it a good idea? Now, there is an overlap between them, but it's not always as simple as you think. Sometimes ethical things may be legal but unethical. Sometimes they may be legal and ethical, but a very bad idea to do. Sometimes they may be illegal, but actually a very good idea to do. Then get into all kinds of interesting questions. But I'm going to look at some examples. Curly fries, I will talk about that particularly. The care data scheme, what I call the Facebook experiment, Samaritan's radar, the Labour purge, and I'm sorry, Charles, I know I've dumped this one on you as an old Labour person. This is an interesting thing in relation to the Labour Party. I should say I am now a member of the Labour Party. And we will look at the safe harbour, and we will look at surveillance, which may not seem like big data, but they are. So let's start off with this story. This is an exercise done in 2013 about how you can predict people's traits and attributes from digital records. And as they say here, we show that a wide variety of people's personal attributes, ranging from sexual orientation to intelligence, can be automatically and accurately inferred using their Facebook likes. And it's a really interesting thing here. This is a kind of big data analysis in the sense that it's all done automatically, but it's also, and critically, something that's done without you having to make the logical connection yourself. And this is one of the big differences between big data and what I would call small data. It's about correlation rather than causation in general. You can notice patterns automatically and use that information. So here's the curly fries question. What they found in that experiment was that liking curly fries was linked to intelligence. So the question is, if you like curly fries, does that show you're likely to be more intelligent or less intelligent? You know? What do you think? Normally when I ask people, I get a wide spread here. Well, the reality is that it actually suggests that you're more intelligent. Whereas if you like motorbikes, you're less intelligent. Now you can start to analyse why that might be. But actually analysing why that might be is not really the point of big data. The point of big data is to identify the traits and then use that information. And the point about Facebook likes, this is why, well, I'm not on Facebook, but which is why they want you to use your likes as much as possible, is they can use your likes to derive more information about you. And you may think the fact that you like curly fries, or you click like on curly fries, whether you actually like them or not is another question, is irrelevant, insensitive, unimportant information. Trivial information. Your level of intelligence would be considered to be sensitive data. So they're using insensitive data and public data to derive private, personal data. And it's just one of the many examples. And let's look at care data. Now, I don't know how many people know about the care data scheme, but it caused a bit of a fuss last year, and it's still continuing to cause a fuss. The idea was effectively to incorporate patient records from GPs, surgeries, into the central data system that's already been prepared in order to do medical research. Effectively, the idea was to gain big data benefits for health, to create a massive database that could then be used for research. And the point about it, and this is also another of the features of big data that's different from small data, is that when you gather the information, you very often don't know why you're gathering it or what results you're going to get from it. Now, under data protection law, you're supposed to specify the purpose when you gather data. Big data goes almost directly against that. You gather the data, you see what comes out, and that's what you use it for. Now, we had many, many issues here. What is research? What constitutes research in terms of health? And I don't think anyone carefully defined it. Certainly the people behind the care data scheme didn't. And who does the research? Now, we're in a university. Universities do research. Everybody knows that. And to some degree, people support the idea of universities doing research into health. Do they support insurance companies doing research into health? Do they support big pharma doing research into health? And who needs to consent to this data? And how do you get that consent? How do you get people to say, I'm happy for my data from my GP to be used for this research? And there are many issues in consent, but one of them is whether you opt in, that is, you say, yes, you can use my data, or you have an opt-out, that is, everybody's data is incorporated unless they object. And that was one of the biggest issues with care data. They went for the opt-out, but they didn't really explain what you were opting out of. And then, and this is also a critical question, who is going to benefit from this research? Again, when you're looking at medical things, everybody wants to contribute to improving public health, to developing cures for cancer, to do all these things. Does everybody want to contribute to the bottom line of big pharmaceutical companies, or to the profits of insurance companies, or to the opportunities people have to actually put your insurance premiums up because they've got evidence that you're more of a risk, or that you might be more of a risk? Because that's another of the critical things with big data. It works with probabilities, and it works with possible outcomes. And we saw that with what Phil was talking about with climate. We've got a range of possible results. With things like healthcare, it's particularly critical because you can suggest a probability, but then applying that to the individual, you could be completely wrong. And the question also with care data was who actually cares about this result? And actually at the time, the man behind big data didn't think anybody would care. And I have to admit, this is me. I created this downfall parody video, which looked as if it was comparing Tim Kelsey with Hitler. It wasn't really, it's an internet meme. But the point was, the people behind this scheme had not considered privacy issues. They had not thought that anyone would care. They thought they could just do this and everything would be fine, and it was obvious what the results would be. But they found that people did care, and there was massive protest on a big scale. And part of this was because privacy issues are about trust, and trust issues are critical to research. In this particular case, even the GPs got involved because they felt that this scheme was undermining people's trust in their GPs. People did trust their GPs, but if they felt the data they gave to their GPs would then be used for something they didn't have any knowledge or understanding of, then they'd be in trouble. The GPs were worried that people would not come to them, would not tell them stuff if they thought that the data would be gathered. People do trust universities, and actually this was one of the really interesting findings about this. People were happy for the research to be done by universities. But people did not trust big pharmaceutical companies, and as a result, their level of trust in big data went down. And care data has just been delayed yet again, a couple of weeks ago. It's been delayed again and again because each time they try to do it, there's such a problem that they find they simply can't do it. Now, this is what when I talk about privacy. If they had considered the privacy issues first, they wouldn't have got into the big mess that they did, because they misunderstood people's understanding of privacy, that people would care and people would want to know what's happening to this afterwards. And the evidence suggests that if people had thought their information was being used in a responsible way by universities, then they would have trusted it more. But as it was, they thought it was being used to help big corporations that they didn't trust. And there were a number of scandals of data having been actually leaked to or given to or sold to insurance companies in particular at the time that this came out. Let's move on. Facebook experiment. Now, this was something that happened again a year and a half ago. They tried an experiment in Facebook, and this used one of the critical big data techniques on social media data. It used what's called sentiment analysis. That is, automatic processing of text to try to work out the sentiment in the text. Now, what they did in the Facebook experiment is they analysed and then manipulated people's news feeds. But broadly speaking, they divided these 689,000 people, which is fairly big data. It's not big like climate data, but it's fairly large numbers of people. They divided them into three groups. One group, they suppressed the happy stories and raised up the sad stories. That is, sad stories and happy stories and analysed according to the sentiment analysis. The second group, they did the reverse. They raised up the sad stories and lowered the happy stories. So they were trying to make one lot happier and one lot sadder. And the third group, they suppressed both the happy and the sad stories and left them with the ones that seemed to be neutral. And what they found was that by raising happy stories, people got happier. Now, they measured their happiness by the same kind of sentiment analysis on the postings that the people were making after it. And the sad group got sadder to a statistically significant degree. And the neutral group, the main result they found was that they spent less time on Facebook. Which is interesting. More interesting, in my view, it's the most interesting finding of them all, and most interesting because what does Facebook want? It wants you to spend more time on Facebook. It may not care whether you're happy or sad. If you're miserable but spend all your time on Facebook, they're quite happy. You'll follow more ads, you'll give them more data and things like that. So there are so many different issues involved in this particular experiment. One was, they didn't tell the 689,000 people that they were manipulating them. They weren't just gathering the data about them, they were actually changing the way their Facebook experience was, and they were actually manipulating their emotions. And more than that, they didn't even tell them that they'd done it afterwards. And there are lots of effects here. Not just the effects on the original people, but imagine Facebook decides they want people to be happier, then they suppress sad stories. Then you've got a sad story you're trying to put out to your friends, that's suppressed. Your cry for help, of whatever kind it is less likely to be seen because Facebook doesn't want people to get upset. And your factual, neutral stuff is less likely to be seen because Facebook doesn't want you to spend less time on Facebook. And most people were not even aware their timelines, what they get to see, were being manipulated at all. So there's a degree of the covert nature of this work is disturbing. Samaritan's Radar. Everyone knows who the Samaritans are. Samaritan's Radar was in some ways... Oh, just to say, somehow that experiment got through the ethics, research ethics panels of a number of major US universities, and frankly, I still don't quite understand how they managed it. Samaritan's Radar also got past the ethics panel of Cardiff University in one particular way. This was a Twitter app, and it's interesting, Ruth was talking about how things can help vulnerable people. Big data analysis can help vulnerable people. This is a way that big data analysis was intended to help vulnerable people, but actually almost certainly had exactly the reverse effect. What it did, you could sign up for the Samaritan's Radar. It would then analyse, through sentiment analysis, the tweets of all the people that you follow, and would identify if those tweets suggest that person is in a vulnerable condition and might be considering self-harm or suicide. It then emails you to say, so-and-so has just tweeted this, they might be feeling a bit down, would you like to help them? That kind of stuff. But the result was people were seriously creeped out by this. And there were many, many reasons they were. One is the way they did the experiment, the way they did the consent, you consented to do the analysis. You didn't consent to be analysed. And actually it turned out when they did the research and did the research ethics and they did the testing, they only tested it from the perspective of the people doing the monitoring, not the people being monitored. And vulnerable people immediately came out and said, there are people here who bully me. If they get to know when I'm at my worst, they'll go for me. And many of them said, I'm not going on Twitter if this is going to happen to me. And it raises the big question, and I think this is something that in big data we have to think more about. Who has to be asked about this information? The same as the care data thing, who should have to consent? And the ethics of this whole idea of monitoring people. This was done for very good reasons, but the result was terrible for people. And the result was partly terrible because the people doing the research did not understand social media. They were developing a Twitter app without actually having any idea of how Twitter itself really worked for the Twitter community. The Twitter community, however, was powerful, and they forced the shutdown of the project within 9 days. This is after they'd spent a year and a huge amount of effort developing it. It was shut down within 9 days. And the main argument that the researchers had is that this data was public. We should be able to do whatever we want to it. These are tweets. But people do have an expectation of privacy, even in public. When you say something, you don't necessarily expect it to be recorded, analysed, and made available to everybody. Think of having a private conversation in the pub with a friend, sitting around a table, whispering. Technically, in public. In practice, you expect that to be private. You don't expect people to be recording it all the time. And this is one of the critical points. The data that was derived from it was this person is in a vulnerable state, which is sensitive personal data about their mental health. You may have taken some insensitive information and derived sensitive information from it. And what is interesting is because it shut down so quickly, the Information Commissioner did not have to do a public pronouncement to say, you've got to shut this down. What they did was tell the Samaritans in private, in a private letter, that this was sensitive personal data. The data that you have derived in itself needed to be dealt with properly. We only found out about this because somebody did a Freedom of Information request on the Information Commissioner, who was a public body subject to freedom of information, and I hope remains so, and found out, did you communicate with the Samaritans? And it was disclosed, this information. Now, this was relatively small data, but the biggest data, any data derived from it, may well be, even if you started with public insensitive data, may well end up being sensitive personal data and require you legally to cover it, as well as being ethically dodgy. Okay, moving on to the Labour purge. Now, for those of you who are too young to remember it, this is Wolf v. Smith, Citizen Smith. When Jeremy Corbyn was looking as if he would probably win the Labour leadership election, there was a lot of worry in certain areas, particularly his competitors, about entryism to the Labour Party. That they talk about Trotskyites coming into, and Wilson Smith was kind of a Trotskyite, at least a joke Trotskyite. And they wanted to remove them to stop them being able to vote in the leadership election. So what did they do? Well, what they did was they used social media data to determine whether or not the people had the aims and values of the Labour Party. Now, they didn't openly say they were using social media. They said that people who did not have the aims and values of the Labour Party would be excluded from it. But actually, they disclosed, there was a particular spokesperson, we don't know who said, one of our real problems is that only 45,000 of these people have social media accounts that we can analyse. Suggesting that that was the approach that was going to be taken. Again, this social media data was probably mostly public, but not all, because some of it was on Twitter, and some people were asked, does this person follow the aims and values? And that might be from private data, which isn't in public, but mostly it was public data. But as with Samaritan's Radar, the derived data, and in this case, a political view, is sensitive personal data, both legally and ethically. And this, many people think, it may well have been, this whole exercise may well have been in breach of data protection law. The Information Commissioner, I do not know if they're investigating, but given the overall results, I don't think anyone really cares anymore so much. But it is almost certainly going to become common practice politically in the future. Now, this was done with small data, because it looks as if what they were actually doing is each constituency Labour Party was going through, trawling through the stuff manually, humans rather than computers. But they could well, and will do in the future, perform sentiment analysis and try to use it to derive this kind of data. It's almost certainly already happening in the US, and I wouldn't be surprised if it's happening here privately. It's used for targeted advertising and things like that, to try to identify people according to profiles. The possibility of deriving sensitive personal data in this way is very high. Right, final thing. This is our lovely friends at the NSA. I still find it rather amazing. This is a genuine NSA logo, that somehow they don't think that's creepy, but they do. Okay, so one of the points about the current methods of surveillance, or at least one of the current methods, because there are many, 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 is that significant amounts of it is big data. By that I mean, it is gathering large quantities of data and then analysing it algorithmically to try to determine traits and to make predictions. The general approach, gather lots or all the data, is what the NSA wanted to do, and some say GCHQ wanted to do as well, and then try to use it to predict. And one of the big questions here is whether the gathering of the data in itself constitutes surveillance, or whether you have to, that the surveillance happens when you algorithmically analyse it, or whether, as is hinted from time to time by GCHQ in particular, surveillance only really happens when human eyes are involved. Now, because of the nature of big data analysis, it's very hard to sustain the argument that it's only the human stage that it can happen, but the argument that it could be at the algorithmic stage is a slightly different matter. Because I think the analysis is when it happens. But just 2 weeks ago, in the Max Schrem's Facebook ruling at the Court of Justice of the European Union, it was effectively said that this kind of surveillance not just invades privacy, but contradicts the essence of the right. And essence is the word they use, of the right to privacy. It's a fundamental breach of privacy. And effectively, it's the gathering that they said constitutes a breach of the essential right to privacy. Now, the implications of that in terms of big data and privacy is significant. And that's because there isn't that much difference between the NSA gathering all our data and a corporation gathering all our data, or a university gathering all our data. And one of the interesting things with the Court of Justice of the European Union is this is just one of a series of very much pro-privacy rulings, from the Digital Rights Ireland case, which declared the Data Retention Directive invalid, which is again on the same basis that retaining all this data was an invasion of privacy, to the Google Spain ruling for the right to be forgotten, which had some relevance in the same way, to now this one on the safe harbour. The safe harbour was what allowed people to transfer data from Europe to the US. But that now has been declared invalid, and everyone is scrabbling around to work out what to do. It was declared invalid because we couldn't trust the NSA. But did the NSA do anything that GCHQ don't do? And it was said in the European Parliament today that the implications of this in terms of Western European surveillance are also big. And what this means is that when you're doing big data analysis on personal and private data, there is a risk that the law will begin to clamp down more on what you do, because the fundamental rights aspects are being taken more seriously by the court. So, many issues. We have issues with how we gather the data, we have issues with the data we've derived, we have issues with how we consent to all of this. And with big data, consent is a big issue because you're not going to get consent from everybody. It's going to be hard, and you need everybody in order for the data to work. Issues with people understanding what's going on, and when you lose the understanding, you lose the trust. Issues with who's benefiting from it. Issues with how the law deals with it. Sometimes the law gets it very wrong. And issues for projects to think through the process. And we have example after example, and I've shown you some of them, of where the thought processes have not been clear and how the result has been a disaster. And issues with trust. How much do we trust what's going on? So that's it from my perspective. And thank you.
Well, I'm sure you'll agree we've had a tremendous set of presentations which illustrate, as powerfully as we could have done, the diversity of issues that are raised by this whole very difficult set of issues. We've got 5 to 10 minutes for discussion and Q&A. Hussein's kindly reminding us, with his expertise in alcohol and food, that there will be drinks available afterwards, and that can continue over that period. I thought it was very difficult to think what were the best ways to deal with a whole set of issues by each presentation. They seem to me to fall into three broad groups. One, the issue about individuals relative to data, privacy, anonymity, a whole set of issues around that. Secondly, a whole set of issues about the methodologies and accuracy of data modelling in terms of being able to establish what happens. How's the data collected? Are the mathematical computer models actually good, competent enough to model human behaviour in the way that's implied, or even non-human behaviour in the way that's implied? How do probabilities, risk fit into that equation? And the third, the whole question of the role of government in all of this, and a subsection of the role of government in all this, the rule of law in all this. What is the legal framework? How is it operated or not? Those are the points that struck me for discussion. So it's over to you. I'm going to take questions in groups of 3, and then I'll ask the panel to answer what questions they'd like to deal with. So I'll start with Rupert, but I'd like to see other people indicating as well. Rupert, can you introduce yourself?
Fundamental methodological question, perhaps for Ruth or others may care to comment. There's a real issue with big data in that as the size of the data set grows, there is an exponentially growing potential for spurious linkages between things to be established. Can you tell us something about how in your actual projects you guard against that risk?
Thank you. Gentleman over there.
Okay, James Comfort. Can I ask a question really to Ruth and Paul? And it's something Ruth said about big data and whether it sustains or destroys sustainable competitive markets. So I think, and actually some of the things that Phil said too, so you can see in some ways big data, especially when you're talking about centralizing data, creating single huge data stores, that's a sort of centralizing way that means that competition as a kind of idea becomes much more difficult because one player holds all of the information, is a gatekeeper to all of the information. And that's also, I think, an issue for researchers. Issues about replication become much harder. Issues about alternative research paradigms and so on become much harder when there's only one route to access the data. I think a second issue is that Paul raised is about information asymmetries in markets. So if access to big data gives the amount of information, potential, personal, private, sensitive information to big organizations that are capable of analyzing it, that means there are huge asymmetries in the way in which markets work, which means that we don't have, as consumers, access to big data. That may undermine trust in the way in which markets operate. And finally, big data seems to have worked with our fundamental trust in institutions. It seems to at least have some contradictory, unsettling impacts on trust, and markets only work where there's trust. So I'm wondering whether big data is something that actually promotes or can promote sustainable, effective markets, or whether it's something that undermines the way that markets work.
Third question before I go to the panel. Lady up there. Take the mic up by the pillar.
Hi, I'm Sophie Garrett. Question for Paul, I think it is, about privacy. Given that it's massively in society's favour and to our advantage if we can extract some really important information from the health data, but given the problems that you've just outlined, which I fully understand, are there any changes, major principles or changes in law that you would like to see that you think would actually enable that analysis to happen, but safeguard things better?
Thank you for the question. I'll go Ruth, Paul, then Phil. Ruth.
Try and remember and respond to some of them. I think the question on spurious association, I suppose it depends on your perspective, but personally I would always come at data analysis from a theoretical perspective of trying to look at identify testing theory rather than just looking for patterns. Now, not everybody come to it from that perspective, and we have people involved in the centre who want to data mine. But my own personal approach to this thing is to think of a theoretical model and test it rather than just looking for random spurious associations. I think on the question of whether the law could do anything different, I'm sure Paul will have more to say on this, but just really an observation from our discussions with local authorities. And I hope this won't be sort of taken the wrong way, but our sense is that concerns about privacy are not the overriding problem. That's not to say they aren't concerned, of course they are. And they have many procedures in place within their own organisations for analysing data and would apply those procedures if they were to share data with us. The fundamental problem, I think, is actually lack of capacity to engage with us on this sort of issue when they have so many other pressing things that they have to do with their time. That's my observation at the moment.
Paul?
Right. On spurious associations, that's how advertisers work, and a lot of the way that big data, particularly in social data and particularly in internet data, has been run by the advertisers, and frankly, they don't care if there's some spurious associations. As long as they get enough hits from enough of the correct associations, they're happy. And this is one of the biggest problems we have with big data in different fields, that they take a logic developed where spurious associations don't matter, and they apply it to situations where spurious associations do matter. And I think it's something that researchers have to be really careful about. And I don't have a solution. I don't know if there is a solution, except that researchers need to be more careful and look for them, be aware that the association that they're making may well be spurious. On the markets thing, in the internet we have a major problem because there are certain markets which are effectively monopolies. Facebook in social media, Google in search, which has more than 90% of the search market in most of Europe, and so on. And frankly, we're struggling. The regulators are struggling. And one of the reasons there are so many rulings at the moment, so many fights with Google, is largely, legal fights with Google, is largely that the regulators really don't know how to deal with Google. They just have some general sense we've got to hit Google a bit because there's something wrong with this overall control. Now that's my opinion. I should say this is perhaps being a little bit unfair to some of the regulators. Each of the issues is important, but there is a sense that we don't know how to deal with. It's not a competitive market in search. It's not a competitive market in social media at all. And the question of whether consumers are benefiting from it is a very, very difficult one. And in terms of the legal changes to help, I think there are several issues here. One of them, and this is a concept we've talked about called privacy by design. It's been mentioned for a very long time from the beginning. If you start considering the privacy issues early and you engage with people who understand these things, you're much more likely to overcome them. Most of the disasters, Samaritan's Radar and Care Data are two of the ones that I use, but there are a whole series of other ones. The main problem has been that the people designing the projects have dismissed privacy as a non-issue until it's come back and hit them on the face. And then you get the disaster. Now, if Tim Kelsey had engaged with the people he thought were tinfoil hat-wearing privacy nuts before pushing his particular design of the Care Data program, I think we could have avoided all of this. And what I mean by that is, if you engage with them, you ask what is the issue that you're concerned with. In the case of health, it is things like, I don't want to give Big Pharma more profits, but I really want to help them give the public health benefit. Design a project that builds that in, that requires, for example, generic drugs developed to be available at a low price, rather than effectively giving free ride to the pharmaceutical companies. You'll get more trust, you'll get less problem, and ultimately, Ruth's right, privacy isn't the main issue. The main issue is what privacy protects. Privacy protects your autonomy in some way, and protects other things. Privacy is not a kind of, it should be seen instrumentally in those ways. And I think that's part of the problem. I mean, Tim Kelsey made a point of saying the health service isn't going to profit out of this. Actually, frankly, a large number of the people complaining would be happy for the health service to profit out of it. They just don't want the pharmaceutical companies and the insurance companies to benefit from it. And Tim Kelsey, because his background is in private health and insurance, he didn't understand that that was what a lot of the objections were about. And he didn't engage with the people. And I don't think it's a legal change that matters, because actually, in many of these cases, they were perfectly legal. And the proposed change to the data protection reform includes terms to allow medical research above and beyond the limits that are used for other things. The problem is, and I said I divided into three things: the legal, ethical, and is it a good idea? And I think it's the bottom two, is it ethical and is it a good idea, that actually matter more than the legal thing. You can generally find a way to sort out the legal things, but if it's ethically wrong and people don't like it, it's much harder to find a way around.
Just briefly, it's not one big data centre either, climate data. It's actually here on the centre. But it's really a distributed centre. So you're actually working with groups, thinking groups from many parts of the world. It's not just Europe and America, it's involving other countries as well. So
Okay.
coming in.
Okay, thank you very, very much indeed. Can we first of all just express our appreciation to the panel and the excellent presentations which they gave us. Thank you very much indeed. Then two other things. Firstly, as Hussein said, there are drinks afterwards upstairs, and feel free to join us in that and put further points to colleagues there if you wish to do so. And secondly, there is a series of events indicated on the leaflet in this series, and I very much hope you'll find interest in coming to those and continuing the consideration of these issues, which has been, I think, so well started out this evening by this panel. Thank you all very much indeed.